Hi again. Welcome to the next video in the functions series. In this video we review the technique of differentiating exponential functions. The exponential function is such an important function and it is used to measure all kinds of natural growth and decay phenomena, including the spread of the coronavirus, the decay of radioactive isotopes, and the increasing love you feel for mathematics as a result of this website. The exponential function is identified by the property that its base of e makes the gradient at any point on the curve, y equals e to the x, equal to the vertical distance from the x-axis, that is, the y value. So if we look at this diagram here, we can note that when x is equal to 1, y is equal to e to the 1, which is e, and the gradient at that x equals 1 is also e. By definition, therefore, when y is equal to e to the x, we can write dy dx is equal to e to the x. This equality between the gradient and the exponential curve with the base of e is not reflected in exponential curves with any other base. The diagram here shows that y is equal to 2 to the x and y equals 3 to the x. In y equals 2 to the x, the gradient is lower than the function values for corresponding x values. In y equals 3 to the x, the gradient is higher than the function values for corresponding x values. So using the basic statement that when y is equal to e to the x, dy dx is equal to e to the x also, we can use the chain rule informally to extend the differentiation of exponentials to contexts in which the index is a more involved function of x. So, for example, if we have y is equal to e to the 2x, now I want you to say to yourself, the e term remains the e term, and we're going to multiply by the derivative of the index. So e to the 2x goes to e to the 2x, just write that down, then multiply by the derivative of the index, which is 2. Tidy it up, it becomes 2e to the 2x. If we have y is equal to 5e to the 3x, then say to yourself, the 5 is a decoration, so it stays there. The e term remains as the e term, so we'll write down e to the 3x after the 5. And then multiply by the derivative of the index, which is 3. So therefore tidy that up, it becomes 15 e to the 3x. If we have y is equal to 12e to the x squared plus 2x minus 13, then dy dx is equal to, the 12 is decoration, write it down, copy the e term down exactly as it is, and then we're going to multiply by the derivative of the index, which is 2x plus 2. Tidy all that up, the 2's factorise out, so we have 24 bracket x plus 1 bracket e to the x squared plus 2x minus 13. Always the same pattern of approach. Negative and fractional indices are treated in the same way as previously. With a negative index, we might have the equation y is equal to 16 over e to the 4x. We can rewrite that as 16 e to the minus 4x. So dy dx is equal to, write down the 16 at decoration, copy the e term, which is e to the minus 4x, then multiply by the derivative of the index, which is minus 4. Tidy up. 4 times 16 is 64, so it's minus 64 over e to the 4x. If we have y is equal to 8e to the x upon 2, then dy dx is going to be, rewrite the 8 at a decoration, rewrite the e term, the exponential term, e to the x over 2, and then multiply by the derivative of the index, which is a half, so we have 4e to the x over 2. Apart from the difference in the results, differentiation of exponentials follows the same strategies as the basic functions which we saw earlier in the topic on calculus basic differentiation. The chain, product and quotient rules are applied in exactly the same way. So for example, if we have y is equal to 2 bracket e to the 2x minus x all cubed, then we do it the same as we did before. The 2 as decoration, leave it there. The 3 as the index comes down the front. Then we rewrite the brackets and we take 1 off the index to make it a square. And then we multiply by the derivative of what's inside the brackets. E to the 2x goes to 2e to the 2x, and the x goes to a 1. Tidy that up a little bit. 2 times 3 is 6. E to the 2x minus x all squared times 2e to the 2x minus 1. Easy. If we have a function in which we have two pronumerals multiplied together, we're going to use the product rule. So we have y is equal to 5 e to the 4x times x squared. My way of approach is write down the first term, write down the second term, differentiate both, and then start on the top right hand side. dy dx is equal to x squared times 20e to the 4x, which we can write as I've done there, plus, because it's a product and like a sum, 5e to the 4x times 2x, tidy that up a little bit, and then factorise out because we have a common factor of 10, we have a common factor of e to the 4x and a common factor of x. Put those down, brackets, and the remaining bit is 2x plus 1. For our quotient rule, yes, we need a bit more room. We're going to do y is equal to 2x cubed over 5e to the 2x. So again, write down the two terms in order. Underneath, write down their derivatives. Start in the top right hand side. So dy dx is equal to 5e to the 2x times 6x squared minus 2x cubed times 10e to the 2x. So we've cross multiplied, and then all over the square of the original denominator, which is going to be 25e to the 4x. Common factors of 10, e to the 2x and x squared outside of 3 minus 2x over 25e to the 4x. We have a cancelling between the 10 and the 25 to give us 2/5, and we have a cancelling from the e to the 2x and e to the 4x, leaving us with an e to the 2x in the denominator. So in summary, exponential differentiation follows from the definition of the exponential with a base of e. Differentiation of an exponential with a base other than e cannot be done directly, but requires a transformation back to a base of e. To keep your mind on the process, especially when you are under stress in an exam, say to yourself, constants in front remain in place. The e term remains the e term. Just write it down as it is. Then multiply by the derivative of the index. Good luck. I know you can do it. So, that is the story of differentiating exponentials. It is a relatively straightforward process, but do it carefully. Talk to yourself. Thanks for watching this video. Hit the like button and subscribe if you haven't already. Also go and do some exponential differentiations and test yourself one on my website at drjaysmath.com. Add a comment below if you have any questions. Good luck. See you in another functions video.